Hi, my name is Sean Bodley with IBM. I'm a high availability and disaster recovery specialist on Power Systems running AIX, and I'll be demonstrating the automated recovery capabilities provided by PowerHA for AIX during an unplanned outage of a production SAP environment. If you have any questions about this demo, feel free to send me an email at the address listed here of sbodley@us.ibm.com. Now, before I show you the demo, let me give you a brief overview of our environment. We have a Power 7 770 running the primary SAP production environment on a partition known as SAP Demo 1. We have a Power 6 570 providing the standby partition known as SAP Demo 2. You can also see that our storage is being provided by a DS4800. Both the SAP data and the system's root VGs are hosted on the DS4800. You can also see on the center of the slide the software levels used in this demo environment. We use these exact levels to fulfill a customer requirement during a proof of concept we performed here in our Dallas lab. Both of these systems are fully virtualized using dual VIO servers for both storage and the networking. Now, let me give you an overview of our VIO environment. This shows our VIO storage access. We truly have 4 VIO servers while there is only 2 depicted here. That is because we have dual VIO servers in each system. All 4 VIO servers have access to the same LUNs, in this case being the shared SAP data volume group LUNs. Now, from PowerHA, it's not a requirement that the VIO servers from each physical server have access to each other's root VG. However, it is a requirement for live partition mobility. Live partition mobility was also another part of the proof of concept we performed. We do also have another recorded demo showing the live partition mobility feature between the Power 6 and Power 7 systems. On the next slide, we show our network configuration. We're utilizing the shared Ethernet adapter capabilities of the VIO server. In our case, we have 2 VIO servers. This provides both adapter redundancy and VIO server redundancy. Then using the shared Ethernet adapter configuration, it's essentially serving up one logical interface to the end client, which is shown here as ENT0. That's a very common practice, and most people like it because it simplifies the overall configuration to PowerHA. You only have to configure one IP address and one interface to the PowerHA cluster topology. Now, with that said, let's get started with the demo. On the top of the screen here, you can see the WebSmith GUI for PowerHA. I've already logged into it. You can see that I have a cluster called SAP Cluster. The nodes are active. The resource group is being hosted on SAP Demo 1. What most people like to see is this association view, which is an overview of my cluster configuration. I have an IP network configured, a disk heartbeat network configured. The shared data volume group is called SAP VG. I'm using the default option of mount all of the file systems. We have an application server which starts and stops the application. In this case, it's named SAP. We have our service IP address called SAP Demo 3, and these are all associated with a resource group called SAP Group. On the top right-hand side, you can see this GUI tool called LPARMON. This is a graphical representation of resource utilization for SAP Demo 1 and Demo 2. I actually like to use it to show the loss of connectivity. Once I take SAP Demo 1 down, you'll see that we lost access to it. On the bottom left is the SAP GUI. I'm already logged on to SAP. SAP is currently running on SAP Demo 1. Not only does WebSmith show me that because that's where the resource group is being hosted, but I will show you that here on the SAP Demo 1 itself. Now, I've also run this command to prove that I'm on a Power 7 system. The 9117 MMB is a Power 7 770. And now that I'll show you that everything is running on this side. So first, I will verify the SAP demo IP address. The volume groups are active. The file systems are mounted. These are the 4 shared file systems that I care about. I have both Oracle and SAP running. There's the Oracle processes. And now for the SAP processes. And I'll prove over on SAP demo that none of those things exist. I am showing that SAP Demo 2 is our Power 6 system. The volume group is active, but it's actually active in what's called read-only mode. The file systems are not mounted, nor are there any SAP or Oracle processes running on the second side. Now, I have 2 windows open to SAP Demo 2 for a couple reasons. One, I'm going to show the event processing in the main HACMP.out in one window, and I'm also going to show a ping of the primary service address SAP Demo 3. Now, the reason why I'm doing this is we'll get a good idea of how long the actual service IP address is gone once a failure has occurred. We'll also get a good idea of how long the overall takeover takes. So with that, I'm going to fail Demo 1. You can fail it by whatever your preferred method is. Reboot -Q, halt -Q. You can fail it through the HMC as a hard failure. I prefer to do a reboot -Q mainly because I don't have to go back into the HMC and restart the partition manually. One other thing I want to note before I actually run this demonstration is this cluster has been configured with nothing more than the defaults. There has been 0 customization to speed this up, nor has this demo been edited to condense the time taken for the recovery to occur. In our test, the demos have taken just a little bit less than 2 minutes, but 2-minute mark has been a good failover time. So with that, I'm going to get started and show pinging SAP Demo 3. It tells me that the IP address is up. I can see LPARMON's running. My GUI's fine. So now I'm going to fail Demo 1. And since I've failed it, I'm going to go ahead and close this window. I can see that my pings have stopped at 13. I can see on the top right that on LPARMON I've lost connectivity to SAP Demo 1. If I come over to my GUI, I'm getting the hourglass, so I can't really do anything. I can see on my other window here that the takeover has occurred. This is the event processing. My pings have started again. It was from 13 to 37, so about 24 seconds that the IP address was gone. And during this time, there was a transition through WebSmith that now says SAP Demo 1 is down. It is actually acquiring the SAP resource group. You can now see that SAP group is up on Demo 2. If I look back over here on Demo 2, I can see that the SAP processes are still starting. So the IP address has already been taken over. The volume groups switched to full read-write mode. The file system's mounted. Oracle started. And now we're starting SAP. And you can see right now that I'm about 90 seconds into this failover. LPARMON has come back to SAP Demo 1. That's just because the reboot has already completed. Now you can see I'm finishing the event processing of starting SAP on Demo 2. There's my banner command that tells me everything's completed. That's about 112 seconds, and I'll prove that I can now log back in to my SAP. So now I'm logged back into SAP, and I can do whatever I want. So everything was up and running. This was just a few seconds less than 2 minutes. 120 seconds would be the 2-minute mark. And I will show the same things that I showed on Demo 1, which is the IP address is there, the volume group is active, the file systems are mounted, and both the Oracle and SAP processes are running on Demo 2. Now, the biggest determining factor of failover time is how many LUNs have to be acquired, how many disks need to be taken over in the event of a failure, how many file systems are there to mount, and usually the single biggest amount of time is how long does it take for the application to recover after a hard failure. So in our environment, we just have 200 gigabyte LUNs that SAP is using. We're failing over in 2 minutes just about any time we want. So of course, depending on how large the environment is, will affect overall takeover time. So with that, I'm going to wrap up this demonstration. I hope you found this useful. Of course, if you do have any questions, feel free to send me an email address at the address I provided at the beginning of sbodley@us.ibm.com.